Hey there guys, how's it going? This is Mike coming at you with another video on number theory. In the previous video, we talked about the floor function, also known as the greatest integer function, and that tells us the largest integer that is less than or equal to a given number, a given real number. And we also talked about its main application in the world of number theory, where we use it to figure out what is the highest power of a prime that nicely divides n factorial for some given positive whole number n. In this video, I want to talk about a particular function. This is a number theoretic function, and we're going to see its use in the next video. And it has other applications to number theory as well as other courses like abstract algebra. So given a positive integer n, a positive whole number n, we define it is Euler's Phi function, or Phi function, however you say it. It's phi of n here. And what Euler's Phi function is, this phi of n, it is the number of positive integers, or number of positive whole numbers, that are less than n and are relatively prime to n. So you give me some positive whole number n, based on how large or small that n value is, we could possibly list out all of the numbers that are less than n and relatively prime to n. As we said, this function, Euler's Phi function, is a number theoretic function, and it is also multiplicative as well. We saw from a previous video, what does it mean for a function to be multiplicative? Well, it's saying that phi of m times n equals phi of m. Let me make that a bit more clear. Times phi of m. So that is just what it means in the context of this particular function. Phi of mn equals phi of m times phi of n. And here's just a really nice small value of n that we can use to showcase. For example, phi of 20 is equal to 8 because the following numbers are all less than 20 and relatively prime to it. 1, 3, 7, 9, 11, 13, 17, and 19. All of those numbers are less than 20, and they don't have any factors in common with 20. So we count the number of these guys: 1, 2, 3, 4, 5, 6, 7, 8, and that's why we say phi of 20 is 8. Now, this is a small value of n. What about a larger value for n? How would we do this same thing? How would we find that how many numbers there are that are less than some large value n and relatively prime to it? Well, realistically, for our purposes, for what's coming after this, we're not going to be using large values of n. So for the most part, we'll be keeping it to things that are fairly small. But how would we do that? Well, we already have, and we already know one of the pieces. We already said that phi is a multiplicative function. The other piece we need is what is phi of n if n is simply some prime raised to some power. So if n is some prime p raised to the power k, then phi of n is equal to p to the k minus p raised to the power k minus 1. So just as a very quick sample here, phi of 81, well, 81 is 3 to the 4th. So phi of 3 to the fourth, my prime is 3, my exponent k is 4. So it's going to be 3 to the fourth minus 3 raised to the 4 minus 1, or 3. So I have 81 minus 27, which is 54. So there's just one very quick use of this formula here. If we combine this fact that we just saw, and that we still see here, with the fact that phi is a multiplicative function, then we can find phi of n for any positive integer n by writing n in its canonical form first. So if we write n as a prime to a power times another prime to a power times another prime to a power, we can use this fact right here and work with each of those primes raised to their own power, come up with those results, and then just multiply those results, and you found phi of n for you found phi for that given positive integer n. But as I said, really for our purposes, we're not really going to be using large values of n. Probably about 3 digits is as large as we would go. So it's worth knowing that, but we're not going to be doing this with massively large things. So now that we know about Euler's Phi function, we can now state a very important result that is used in this course in number theory, as well as abstract algebra, and that result is Euler's theorem. And that is actually what our next video is going to be dedicated to. It's going to be a fairly short video there. So this was the introduction to Euler's Phi function that I wanted to provide you in this video. Just some formulas to help you figure that out for any positive integer n whatsoever. As I just said, in the next video, we're going to see how we use this phi function in the world of number theory. If you have questions or comments, be sure to drop them in the comments section below. Otherwise, until the next video, take it easy, guys.